angled brackets refer to like these special directories in the file system, in the operating system that it knows to look in to find these files. So like foundation/foundation.h is in one such special directory, whereas these double quotes are what you're going to want to use to refer to files in your current project. So in this project, I have a student plus student compare.h file. Double quotes is like relative to my current location, whereas angled brackets automatically goes to these special directories. Yeah?
You can add addendums to existing, like for example, like if there was another like file system, or I'm sorry, like something to the extent of foundations, but you wanted to add an addendum to that, you would use that syntax for doing that as well, or?
Do you mean by addendum, do you mean like this sort of stuff, this category stuff?
Yeah, exactly.
Oh, then yeah, so in student compare.h, well, let's say student.h was a foundation class. Yeah, exactly. Then I would do foundation/student.h. And inside of main, I would still do student plus student compare.h. I wouldn't import the original foundation version of things. I would import my version of things that have been overridden.
What you're doing with this external student.h is you don't inherit it, but you do a wraparound, right?
Yes, it's actually just an extension. It is the same class, and anywhere else in your code that uses that class could also use that new method. If it doesn't happen to hash import the correct category file, the compiler will complain that like it doesn't know that method exists. But that method now actually exists for that class. Mm-hmm.
Where's NS comparison result coming from? Is that a library?
So that's something in foundation/foundation.h. We could actually just look it up. NS comparison result. So something about the Apple documentation is that it can be overwhelming, but it has a lot of good examples. So feel free to ask questions on like the message board if you just find yourself lost in a path of various methods and stuff. So data types, what was I looking for? NS comparison. So it looks like NS comparison result is, all right, this syntax you don't even know yet. Let's hold on for that. That's going to be the next thing. But NS comparison result is just something that Foundation defines, and that's why I wasn't 100% sure what it is. I just know that the compare methods of NSString and NSNumber also return NS comparison results, and so that's what I used. But if you wanted, you can construct your own NS comparison results to return. Okay. Questions before the next thing? So, next thing is this. Again, I think the slide's going to be worthless. So blocks. So that's the general format of blocks, but that's worthless. So looking at the example of using a block, Okay, so back to student.h and student.m. I have not modified them to include a compare method. I've not added a category to extend the class. Instead, I've used what's called a block. So a block is kind of like an anonymous function in other languages. It doesn't even have to be anonymous. If you wanted, you could assign it to a variable. It's kind of like, if you're familiar with the term, it's like giving Objective-C first class functions. So like in Objective-C, I'm not really able to just define a function in the middle of this method. That's not entirely valid. Whereas I am able to define a block. So just like in JavaScript, you saw a syntax like this. Here, we are using a different method. So before we used sorted array using selector. Now we're doing sorted array using comparator. And so this comparator expects a block that this little caret symbol specifies that what is following this is a block. And this is the return type of the block, NS comparison result. This is the this is the type of the first argument, this is the type of the second argument. And I know this because if I look at the documentation for sorted array using comparator, its argument is supposed to be a block that returns an NS comparison result and takes two arguments that are both IDs. So this I got directly from the documentation. And then I need to define the function itself. So I have my little curly brace. And in here, I'm doing the same sort of thing I did before. We see here that I cast A to a student star. And that's because in here, A is just an ID. And here, B is just an ID. So if I actually want it to be a student object, I first need to cast it before passing it name. So student star A name, student star B name gives me these two names, and then I use the NS strings compare method. So I don't have to construct my own NS comparison result. And we know that this appropriately returns an NS comparison result like this says it should. So blocks anonymous functions. The syntax is a little strange, but it's convenient that like I don't need to define a method in the student class just to sort this array, which like that was a very heavy-handed result just to get a sorted array.
Can you assign a block to a variable?
Yes, so that's where, oh, I'm not going to remember the syntax, but it's going to look something like, so it's something like what it returns, and then in parentheses what I want to call it, and then ID equals, and then pass it to here. Didn't complain. So if you're familiar with function pointers in C, I just sort of used that same syntax. I replaced the star with a caret. So here is, we are defining a variable called func that is a block as indicated by this caret. This is the return type of that block is NS comparison result. The arguments are two IDs, and we are assigning that to this block. And then we're passing that variable to that function, to that method. Questions? Okay. So, a couple last things. Okay, so protocols. We're not going to go into deep detail today about them, but they are going to be pretty substantial in your iOS usage. So the syntax for this, remember that, well, inner interface, we would also say like :NS object, but here, this angled bracket syntax is how we're going to specify that it must adhere to some protocol. And so the NS copying protocol, this is where I'm saying a protocol is kind of like interfaces from other languages. By saying that the student interface implements the NS copying protocol, I'm saying that it must implement the methods that NS copying says. Anything that implements me must implement. So looking at the implementation now, if we look at NS copying, it says that you must implement a copy with zone function method. And so here's us implementing it. You don't really have to care about the syntax of it for now or what it actually is doing. So the idea is that since student implements the NS copying protocol, it must implement all methods that NS copying says. And the use of this, as we see, is going to be like a lot of these functions that, or a lot of like classes that you're going to be using with iOS, like a lot of these drawing classes are going to expect you to pass it objects that must adhere to certain protocols. For example, UI table view is one. Let's actually look at documentation. This documentation will work. Okay, so we see in the documentation that, let's look at data source. So UI table view is in like your iPhone, it would be like your contacts list sort of. It's just like a bunch of rows with data in them and you can scroll up and down on it. So